No. All right. All right. So y equals x squared. So if we want to find the slope, any point on that curve, okay, we should take the derivative of it. So let's figure out. Well, the other day we were doing slopes with this. And from 0, 0 to 1, 1, we know that the slope from 0, 0 to 1, 1 is 1. But let's find the slope at 1. At 1, 1. What is the slope? Well, the other day we said, well, let's take 1.0001. And if we... What was that? My goodness, I thought I hung up. Okay, so what's 1.01 squared? Well, it's 1.00020001, right? And then if we find the slope from 1, 1 to this point, just past it, we get 1.00020001 minus 1 over 1.0001 minus 1, which is 0.00020001 over 0.001, which is 2.001. So the slope at 1 is probably what? 2. And then if we want to find the slope at 2, which is the 0.24, I wonder what the slope is there. Well, if we find the slope, if we go 2.01, and then if you square it, it'd be 4.040. No, I don't know. What's 2.01 squared? You'll have to help me out there. 0.0401. Okay. And then if we go 2 and 4, or well, 2, 4 as our points, so we go 4.0401 minus, it's Dactronics, yes, just a second. Hello. Good. Our all sport character generator, we're supposed to get a warranty 1. And so I was just wondering when it would be shipped. And so that's why the guy forwarded my call to you. And then it was taking a long time, so I just put it in the queue. No, because I thought that would just travel over with a phone call, but then once we went in the queue, that disappeared. So it's Madison High School, Madison, South Dakota, and should be the most recent thing that's going on. I'll be back. No, we don't need service. It's just a character generator, just a little box. Yeah. Yeah. Because he said it was in stock. But now, does it have, is the stuff in stock have radio as part of it? Okay. 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 Sounds good. Yep. Well, as soon as we can, yeah. Okay. Yep. Okay. Okay. All right. All right. Thank you. Bye. Our electronics warranty expired 5 days ago.
What?
So we got to figure out.
We gonna get our stuff or?
Yes. Yes. She said since it expired within the last 5 days that it'll still be covered. They're going to cover it.
Kind of an invoice.
I don't know.
It usually came from Brad, is the one that usually emailed it to me. So I wonder if it went to.
Maybe it went to Brad's email and it just. So, do you want to figure that out, please? Because that is way too important not to have that stuff covered under warranty.
Yeah, I agree.
So, okay. Thank you. Okay. So, we get, if we subtract these, 0.0401 over 0.01, which is 4.01. So, at 2, what is the slope about? 4. Okay, and you're thinking, well, 1 is 2, 2 is 4, 3 would be 6. So it's just the first derivative of this is just twice the x value, right? Now, what's the relationship between this and this? Well, let's do another derivative once. Let's say y equals x cubed, the graph that looks like this. Okay, now I'm going to tell you that the derivative at 1 is going, or at 1, 1, your slope is going to be 3. At 2, 8, because 2 squared is 8, at 2, 8, your slope is going to be 12. At 327, your slope is going to be 27. Okay, so what happens here is the first derivative is 3x squared. Okay, let's look at the relationship here. Let's look at the relationship here. Notice anything yet? Notice any patterns? Well, if y equals x squared plus 5x plus 6, the first derivative will be 2x plus 5. Any patterns yet? Nothing. Let's say y equals x to the fourth. Then the first derivative is 4x cubed. Anything yet? See a pattern? Picking up anything that I'm putting down? So if y equals x to the fifth, what do you think the first derivative is? 5x to the fourth? Oh, you're picking up what I'm putting down. Okay? This is called the power rule. And instead of having to do all this math, we can just look at the function and figure out what the derivative is just by looking at it. And when they discovered that, this made calculus like cool and like, oh, ooh, this makes it so we can find slopes of any curves really fast. What is the power rule? Well, it is on your sheets somewhere, but it's x to the n. If f of x equals x to the n, the first derivative of that is n x to the n minus 1. You take the coefficient and you take the power and make it the coefficient, and you drop the power by 1. That's the power rule. The power rule is extremely important in calculus. Okay? You will use the power rule the entire rest of the year. Okay? When you're doing derivatives and when you do antiderivatives, you'll have to remember the power rule to do an antiderivative. So, let's look at these. So what's the first derivative of x to the 12th? You should say it is 12x to the 11th is what the whispers are saying. But what if we have x to the negative 9th? Well, that is negative 9x to the negative 10th. Negative 9x to the negative 10th. Now, they say, what is the first derivative at 2 of this one? Well, we can figure that out. First, we have to find the first derivative of this function. The first derivative of this function would be negative 5x to the negative 6th power. Well, what is a power to a negative exponent? It puts it where? If it's in the numerator, it puts it in the denominator. So really, this function is negative 5 over x to the 6th. Now let's put 2 in there. What is 2 to the 6th power? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So it's negative 5 64ths. That is the slope at 2. That is the slope of the function at 2 of the graph. That's x to the negative 5th power. Because x to the negative 5th power, that function is 1 over x to the 5th, which looks like this. Okay, it's that type of looking power. So at 2, the slope is negative 5 64ths. Woo. So at 2, the slope is like that. Okay? So that's what's going on there. Now, the ones that aren't fun are fractional exponents. Okay? Because this would be 2/3 x to the 2/3 minus 3/3. What's 2/3 minus 3/3? Well, it's 2/3 x to the negative 1/3, which is the same really as 2 over 3x to the 1/3. Now, if we are fine with leaving a fractional exponent in the denominator, okay, that's fine. But when we get to square root functions, we'll actually have to get that square root up to the numerator. Okay, for right now, I think we're fine leaving it where it's at. Okay, let's do this one. X to the 1/4 power is 1/4 x to the what power? What's 1/4 minus 1? Negative 3/4. So it's 1 over 4 x to the 3/4 power. Because x to the negative 3/4 goes to the denominator, become x to the positive 3/4. So it's 1 over 4 and then 16 to the 3/4 power. What's 16 to the 3/4 power? Well, it's 4 times 16 to the 1/4 power cubed. 16 to the 1/4 power. What times itself 4 times is 16? 2. So it's 1 over 4 times 8, which is 1 over 32. So the slope at 16 is 1/32. We can find the slope at any point on any graph. If you know the function, we can find the derivative. Devin tries to find the derivative of negative 3x minus 11 using basic differentiation rules. Okay? So he takes the derivative of negative 3x and he takes the derivative of minus the derivative at 11, which is fine. So he takes the derivative of negative 3x, and well, the derivative of a whole number is going to be 0. Okay? Why? Because if we have x to the 4th, it's 4x to the 3rd. If we have x to the 3rd, it's 3x squared. If we have x to the 2nd, it's 2x. If we have x to the 1st, it's just 1x to the 0 power. Okay, and what's x to the 0? What's anything to the 0 power? 1, so it's 1 times 1. So then if you have x to the 0 power, it equals 0 times x to the negative 1. And 0 times anything is 0. Okay? So 11 times x to the 0 power, because 11, if you put a variable on it, it would be times x to the 0, because anything to the 0 power is 1. So if you take the derivative of that, you get 0 x to the negative 1st. Okay, so this is fine. If we take the derivative of that, you can take the negative 3 out and take the derivative, and you get that. So he says the derivative is negative 3. At which step did he make a mistake? He did not make a mistake at all. The derivative is negative 3. But Connor does it, and he says, well, let's take the derivative of this. So we take the derivative here, and as we work down, he gets the derivative of negative 2. He made a mistake. Where's his mistake? Step 1, he's fine. But step 2, he said the derivative of 5 was 5. What's the derivative of 5? 0. It should be 0. So step 2 is where he made his mistake. Jasper was working. Do you see Jasper's mistake? First step, he's good, right? Second step, take the derivative of 6, you get 0. Take the derivative of negative 9x. So then he split up these two. He split up the negative 9 and the x. So you took the derivative of negative 9, which is 0, and took the derivative of x, which is 1, which gives us 0. What's his mistake? Well, you shouldn't take the derivative of the coefficient. Okay, the coefficient can go up front, like what they did up here. The coefficient can go out front, and then you take the derivative of the variable. So that's where you made his mistake. So at step 3 is where you made his mistake. Okay? All right. So here, the following table lists the values of functions g and h and their derivatives g prime and h prime at x equals negative 2. So what is the derivative of this function at negative 2? Well, when you take the derivative of 4g to the x, it's 4 times the first derivative of g. You take the derivative of h, it's the derivative of h. And then the first derivative of 8 is 0. So it's 4 times whatever's up here, negative 5, plus 7. Or negative 20 plus 7, which is negative 13. So you just take what they have on the list, and we're going to use these tables a lot when we get to the product rule and the quotient rule. We'll use these tables a lot. This is fairly simplistic. You take the derivative and you write it down. And this right now do not matter very much. Okay, for this one, it's 3 times the first derivative of f minus 2 times the first derivative of h plus the first derivative of 6 is 0. Okay. So it's 3 times 5 minus 2 times negative 6, which is 15 minus a negative 12, which is positive 27. Okay, so there we go. I think this will probably be enough for today, and then we'll do another section Friday. Unless you guys all come back way early from your NCRC, then we'll maybe do a section Wednesday. I don't plan on you being here Wednesday. All right, so let me put that next section out.